In this class, we solve some of the problems on Hilbert transform. So to summarize the learnings of the previous class, we learned definitions of Hilbert transform, time domain analysis of Hilbert transform, frequency domain analysis of Hilbert transform, and some of the proofs of properties of Hilbert transform. So in today's class, we'll solve some problems on Hilbert transform. So the first problem is find Hilbert transform of x of t is equal to delta of t. This is delta of t is nothing but impulse function. So by definition, in time domain, we can write the output y of t is nothing but Hilbert transform of x of t given by 1 by pi integral minus infinity to infinity x of tau by t minus tau into d tau. So what is x of t here? Delta t. What is x of tau? So I am going to consider it as delta tau. So I can write the expression by substituting x of tau as delta tau here. So impulse function exists here at tau is equal to 0. Therefore, rewriting this expression, integral minus infinity to infinity delta of 0 into 1 by pi t into d tau. So what is delta of 0? It is 1. Therefore we are going to get here 1 by pi t. What is Hilbert transform of delta t? That is nothing but 1 by pi t. So the second problem is like this. Find Hilbert transform of x of t is equal to sine 2 pi fct. Here we have to introduce a 90-degree phase shift to this signal. This is time domain analysis. Therefore, Hilbert transform of x of t is given by sine of 2 pi fct. You write as it is and introduce a phase shift here minus pi by 2. So rewrite this expression sine of, take minus outside and write pi by 2 minus 2 pi fct. So simplify here, sine of minus theta is minus sine theta. So write here minus sine of 90 minus theta. So what is sine of 90 minus theta? It is cos theta. Therefore here you have put minus here. Similarly, if x of t is cos 2 pi fct, then its Hilbert transform by applying the same principle, you will get sin 2 pi fct in a similar fashion. So let us try to understand Hilbert transform of x of t is equal to cos 2 pi fct plus sin 2 pi fct. So in problem 2, we have solved Hilbert transform of sin 2 pi fct and cos 2 pi fct. So repeat these steps in order to find the Hilbert transform of cos 2 pi fct and sin 2 pi fct. What is Hilbert transform of cos 2 pi fct? It is sin 2 pi fct. What is Hilbert transform of sin 2 pi fct? It is minus cos 2 pi fct. So this is the answer. So now let us consider some exponential function. You have to find Hilbert transform of x of t is equal to e to the power of minus j 2 pi ft. So this exponential function can be written in the form of cos theta plus or minus j sin theta. That is, exponential of plus or minus j theta is written by trigonometric function cos theta plus or minus j sin theta. So what is x of t here? X of t is cos of 2 pi ft minus j sin 2 pi ft, because I have here minus sign. So what is Hilbert transform of this x of t? What is Hilbert transform of cos 2 pi ft and sin 2 pi ft? You introduce phase here. So cos 2 pi ft minus pi by 2 minus j sin 2 pi ft minus pi by 2. Now you simplify this. Cos of, you take minus outside, pi by 2 minus 2 pi ft minus j sin of minus pi by 2 minus 2 pi ft. Now you simplify. What is cos of 90 minus theta? It is sin theta. What is sin of 90 minus theta? Cos theta. But you observe here, we have to express this in terms of exponential signal. Here sin comes first, cos comes next. Therefore, you take j outside. When you take j outside, it becomes cos 2 pi ft minus of j sin 2 pi ft. Even though you multiply this, you will get the same expression. J cos 2 pi ft, j square is minus 1. Therefore, we have minus sign here. Minus into minus 1 is plus 1. Therefore, we will get sin 2 pi ft. So, what is this expression? Cos 2 pi ft minus j sin 2 pi ft. It is expressed in the form of e to the power of minus j 2 pi ft. So, what you have to write the answer? J into e to the power of minus j 2 pi ft. So, this is the answer for this problem. So, now let us consider a rectangular function defined by this value. So, given x of t as a rectangular function defined by 1 for t greater than minus half less than half, 0 otherwise. So, we have to find the Hilbert transform of this. How to find? So, let us write Hilbert transform in time domain x cap of t as convolution of x of t and 1 by pi t. What is 1 by pi t? It is h of t. So, now you write the equation in time domain, that is convolution integral, that is equal to, you write the value of the time over which this x of t exists, that is minus half to half. Rectangular function is having amplitude 1, therefore 1 into 1 by pi into t minus tau into d tau. Now let us go for substitution integration. Here I have t minus tau. So put t minus tau is equal to x. So minus d tau on differentiating, minus d tau is equal to dx. So you have to now change the integration limit. So when tau is equal to minus half, what is this x value becomes? It becomes t plus half. When tau is equal to half, what is the value of x? It is t minus half. So now change the integration level with respect to x. Now t plus half to t minus half, 1 by pi, you substitute t minus tau as x and minus dx you write here. So take minus outside, minus 1 by pi. What is integral of 1 by x dx? It is ln x. Substitute the integration level here. On substituting integration value here, that is level here, we'll get minus 1 by pi ln of t minus half minus of ln of t plus half. So you multiply this. This is nothing but 1 by pi into minus ln of t minus half. Minus into minus is plus, ln of t plus half. This is nothing but ln of a minus ln b. That is nothing but 1 by pi into ln of a by b. So this is the possible solution for this function x of t. So in the next class, we'll solve some more problem on Hilbert transform.